Okay, I'm going to continue on this proportion problem with the central limit theorem. We've gone ahead and checked the assumption. We found our mean and our standard deviation of the sample. I'm going to answer two questions. They first ask, what's the probability that she wins half of her cases? So we're going to do that as part one, half of her cases. Now we can find the proportion, or p hat, of the number of cases by doing the number of cases over n. But in this case, because we know it's half of her cases, we can just say the probability that p hat is greater than 0.5. Now we can put this in the calculator. I'm going to show you again how to use it on the table. I'm going to need to standardize it, so I'm going to find the z-value, which means I'm going to do x bar minus mu over the standard deviation of the proportion. Oops. Okay, so that is 0.5 minus 0.4 divided by 0.0693, and that's why I found that information beforehand. Now you can put the whole thing in your calculator with the square root of 0.4 times 0.6 divided by 50 to make it more accurate. But I'm going to go ahead and round up to three significant figures and use 0.0693 just for our purposes. Now when I put that in the calculator, it gives me a z-value of 1.443. So because I'm using my tables, I'm going to grab my e-table here for the standard normal distribution, and I'm looking for 1.4, and then at the top I'm looking for the second 4 in the decimal. So this is 1.44, and that gives me a value of 0.9251. Okay, now, is that our answer? 5-1? 5-1. I need you to be very careful. The table is giving us the area below that z-value. So our z-value is 1.44. The table is giving us the shaded region below that. We want the probability that it's greater than 0.5. So in reality here, I need to do 1 minus 0.9251 so that I can get the area that's above the z-value, so we can get a greater number. That number is 0.0749. So that tells us the area under this curve, or the probability that she wins 50, half of her cases, is about 7.49%. Now if I were to do the second part, the probability that she wins at least 30 cases, that's the probability that x is greater than 30. So in this case, I'm going to do 30 divided by 50 to get my proportion, which gives me my proportion is 30 over 50, or 3/5. Well, just a second. You could also use 0.6. Since we're using decimals anyways. Okay, so I'm going to do the same exact thing over and over again. Same thing. We're going to find our z-value. So that's going to be 0.6, the number that we're looking for, minus the mean, 0.4, divided by the standard deviation, 0.0693. Okay, and I put it in my calculator, and no, I told you that I was going to put this in my calculator. That's just what I'm writing. I am putting the whole standard deviation in there, but that's just so I can be accurate. If you don't, that's okay. I'm going to change that. 2.887 2.887. Oh, wow. Okay, 2.887 is a very large z-value. It's going to give us a very small area to the right-hand side. Okay, so I'm going to use my table, and I'm going to look for 2.88. There's 2.8, so now I need to find the other 0.8 at the top and find 2.88. Oof, hang on, I'm getting old. There we go, 0.9980. Now again, and there's always a picture on here to remind you this is the left-hand side. So if we say that she's got a 99.8% chance to win 30% of her cases, we'll be on the wrong side of this. So we have to do this number minus 1, which is the entire area underneath the curve. So we're going to do 1 minus, our number was 0.9980, and we get 0.002% chance that she's going to win 30% of her cases. So a 0.2% chance that she wins. What is it? That she wins at least 30 of her cases. Okay. Central limit theorem means that I can use a z-value to answer these probability questions because they are approximately normal as long as the assumptions are met or as long as my sample size is large enough. There are more problems on this handout. I can fill it in and I'll load it onto the D2L if you need anything.